Hello, it's just Miss Sullivan talking trigonometry. So trigonometry can seem a bit daunting until we sort of just appreciate that trig means triangle, metry means to measure. So trigonometry is really just about measuring triangles. So we study trigonometry with ratios because basically trigonometry is all about the relationship between the sides and angles of a triangle. So we can work out one provided we know two of the others. So let's have a little look. The first thing we need to do is, in order to work out these relationships, is to name the participants. So let's look at naming the sides first. We already looked at Pythagoras. So we know that in a right-angled triangle, the side that is opposite the 90-degree angle, and don't forget, don't assume it's 90 degrees unless you see the square. The side that's opposite the 90-degree angle, we call the hypotenuse. That doesn't change. The next step with trigonometry is to pop in a reference angle. It's that little zero with like the squiggle through the middle. That's our reference angle. And the side that is opposite the reference angle is called the opposite. And the side that runs adjacent to the reference angle is the adjacent. So it's also kind of easy to remember because it's the only one left over after you've labelled the other two. The reason the reference angle is important is I could make, this will always, so here's my 90-degree angle, the side opposite the 90 degrees will always be the hypotenuse. But this time, so you can see that I made that one the reference angle last time, if I make this the reference angle, this side becomes the opposite. This side becomes the opposite, and this side becomes the adjacent. So when we talk about our relationship between the sides of a triangle, we've got to remember it's in relation to a reference angle. So let's have a little look at the nature of these relationships. So I'm just going to move the camera down so you can see them all at the same time. Good, everything fits in. Great. So there's three main relationships. They're called sine, cosine, and tangent. So the sine in relation to my reference angle is the relationship between the opposite and the hypotenuse. The cosine in relation to my reference angle is the relationship between the adjacent and the hypotenuse. And my tangent in relation to my reference angle is the relationship between the opposite and the adjacent sides. So to remember this, heaps of people use the mnemonic so katoa. So remember sine, opposite hypotenuse, cosine, adjacent hypotenuse, tangent, opposite adjacent. That's so katoa. And I'll say that a lot as we're going through. I think the best way to explain what we mean by the nature of these relationships is to just look at a triangle. So I'm going to have a look at this triangle. I'm just trying to fit the whole thing in. And you can see that this side is 10 centimeters, this side is 8 centimeters. So let's have a little look at naming our sides. So I know that this side, which is opposite my 90-degree angle, this side has to be the hypotenuse. I could use Pythagoras' theorem to work it out. So I know that the square of the hypotenuse is equivalent to the square of the sum of the other two sides. So what I want to work out, what I want to show you now is the relationship between the sides. So actually we might start by just working out the hypotenuse. So I'm going to call my hypotenuse h. So for the moment, let's just work it out. We've got 10 squared plus 8 squared equals hypotenuse squared. So 100 plus 64 equals h squared. So h squared equals 164. H is going to equal the square root of 164. I'm just going to quickly find out what h is. So trusty little calculator, here we go. Square root, there's the button again. Square root of 164 equals 12.80624847. So I'm going to pretend that we've been asked to round this to one decimal place. So let's look at the second decimal place. Oh, good, it's a 0. That means it's definitely below 5. 8 will stay as 8. So it equals 12.8. And let's remember we're working in centimetres. Yeah, 8 centimetres, 10 centimetres. 12.8 centimetres. Terrific. The first thing I want to have a look at is, sorry, I'm just finding another little piece of paper. The first thing I want to have a look at is the relationship called sine. So let's have a look at that. And we've remembered that sine, so I'm just going to write down so, ka, toa to remind myself. So, in order to be able to look at opposites and hypotenuse and adjacent sides, I'm going to need to know what I'm talking about. Let's make this our reference angle. So that's my reference angle. I know that over on this side, that's going to be my opposite. And I know that what's running along the bottom here, so the one that runs adjacent to my reference point will be the adjacent side. So let's have a little look here at what we get. We're finding sine. So sine, and I'm just going to call it sin now because I really quickly want to show you the buttons on your calculator that we're talking about here. Sine, cosine, tangent. So from here on in, I'm just going to go, when I say sine, I'm going to write sin. When I say cosine, I'm going to write cos. And when I say tangent, I'm going to write tan. So sine in relation to my reference angle is going to equal, so opposite over hypotenuse. My opposite is 10 centimetres over my hypotenuse, 12.8. 10 over 12.8. Okay, so 10, and I know that that just means divided by 12.8 equals, now this time I'm not going to, I'll round it to 2 decimal places again. Decimal place 3 is a 1, so this stays at 0.78. Excellent. All right, let's find the cosine in relation to my reference angle. So ka, I know that that's the adjacent over the hypotenuse. So this time I'm finding my adjacent, which is 8 centimetres, over my hypotenuse, 12.8. So I've got 8 over 12.8. So let's have a look at 8 divided by 12.8, and I end up with 0.625. 0.625. Cool. Now let's look at the nature of our relationship between when we look at the tangent of our reference point. And we know TOA, the tangent is the relationship between the opposite and the adjacent. So the opposite side being 10 and the adjacent being, I can see it sneaking over there, 8. So 10 divided by 8 equals 1.25. Equals 1.25. Excellent. Now, if I wanted to reduce this triangle by a scale factor of 0.5, so essentially I'm going to keep all of my angles exactly the same, and I'm just going to shrink it in half. So if I want to decrease this, I'm going to reduce it to a scale factor of 0.5. I know that 8 times 0.5 is the same as saying 8 divided by 2. So let's make this bottom one, let's make this second triangle 4 centimetres. Excellent. And 10 centimetres multiplied by 0.5, I know that's the same as dividing 10 in half, and this is going to be 5. So I'm going to draw a new little triangle. I'm going to draw my triangle inside this triangle. So we've got similar figures here. I know this one now is 4 centimetres and this one is 5 centimetres. And I'm going to keep the matching reference point. So this is still the opposite and this is still, that side is the adjacent, but now the opposite is 5 centimetres and my adjacent is 4 centimetres. Let's work out my hypotenuse again. So it'll be 5 squared plus 4 squared equals h squared. So 25 plus 16 equals, let's have a look, 25 plus 16, sorry about that, equals 41. So if h squared equals 41, then h must equal the square root of 41. So square root button, and my answer down here equals, we'll round this to 2 decimal places and we'll make it 6.41. H equals 6.41 centimetres. Okay, so if I want to work out now, so I'm having a look at this triangle and I know that the angles are going to be the same because it's a similar figure. I've reduced it by a scale factor of 0.5. Let's have a look at the nature of the relationship. Sorry, wrong little piece of paper. Again, the side of my reference angle, this time it's going to be 5 over, and let's just check how good was my scale. So 12.8 times 0.5 is 6.41. Pretty terrific. That's a pretty good scale. My scale factor is obviously working. These triangles are definitely similar figures. So I'll make it 5 over 6.4, which means the cosine, which is going to be the adjacent over the hypotenuse, the adjacent over the hypotenuse, this time is going to be 4 over 6.4, 4 over 6.4. And now I'm going to look at the tangent, which is the opposite over the adjacent. Opposite being 5, adjacent being 4. Let's have a look at what happens when I do these sums. So 5 divided by 6.4 equals 0.78. Check, check. Yes, it does. 4 divided by 6, can you see that one? 4 divided by 6.4 equals 0.625. Yes, it does. And 5 divided by 4 equals 1.25. Yes, it does. So what you can see here, and the whole purpose of doing this little activity with the scale triangles, was to show you that from this triangle to this triangle, because the angles are the same, and they're going to be the same because it was a scale drawing, so side, side, side means I've definitely got a similar figure. It means that the angles, 90 degrees, these two angles are going to be identical, and so will these two. If we have a look, what sine, cosine, and tangent tells us is the nature of the relationship between the angles and the sides of a triangle. Terrific. That's really helpful when I want to look at things like working out, no, I don't want to work that out yet. I'm going to do that in a completely different video. What I'm going to do here is just show us what it can look like, what we can do when we've got these ratios. So this time I've got a 90-degree triangle. I know that this is going to be my hypotenuse. I've got a 60-degree angle. That's my reference point. So this time, what I've got, the side opposite is y. So what I've ended up with is my opposite and my hypotenuse. Okay, what ratio do I know that involves the opposite and the hypotenuse? So katoa, so sine is opposite over hypotenuse. So sine of a reference point equals the opposite over the hypotenuse. So now I just substitute in the values that I know. I know that the sine, in this case my reference point, I've got an actual angle. So I substitute in my actual angle for this reference point, equals the opposite, which is y, over x. And what I was going to show you first was how to work out unknown sides, but for now, this is enough. My reference point this time is an actual angle, and I'm going to use sine because this is the information that I've got. I've got my opposite and I've got my hypotenuse. Let's have a look at this one. This time, I do not have a hypotenuse, but I do have my opposite and I do have my adjacent. So, car, no, that's adjacent over hypotenuse. Toa, oh, that's opposite over adjacent. So, because I've got the opposite and I've got the adjacent, that's what I'm working with. I know that the tangent of a reference point can be found by dividing the opposite by the adjacent. So, again, I don't just have a reference point, I've got a real angle this time. So I can say tan 30 degrees is my opposite side, in this case, Z, divided by the adjacent. So as you can see, if I had actual lengths for those, I could work out the rest of the triangle. Kind of cool. So what I was doing there is showing you how to work with the data that you've got. And what was really important to remember all the time, so, ka, toa. So, ka, toa. Just to finish, I want to quickly show you how your calculator works. So, before you begin using sine, cos, and tan on your calculator, please make sure that it is set to degrees. You know it's set to degrees. I'm just going to try and hold this up. If it's got a little, hopefully you can see that, a little D there. So to do that, you hit Shift, Mode, and then you pick number 3 for degrees. Excellent. And then we pointed out, these are your buttons, sine, cos, and tan. So let's just have a little look here. You can literally punch in the sine of 30 degrees. So if I've got an angle of 30 degrees, as I do here, the hypotenuse and the opposite, the hypotenuse and the opposite and the adjacent will all have the same relationship. So what is that relationship? So sine is opposite over hypotenuse. So, SOH, opposite over hypotenuse. And so 30 degree, if I've got a 30 degree angle, the relationship between the opposite and the hypotenuse, I can find out just by typing in sine, and you see the first bracket comes up by itself, 30, close my brackets, enter, 0.5. So regardless of what those sides actually are, regardless of what my opposite is, regardless of what my hypotenuse is, if I divide my opposite by my hypotenuse, sine of 30 degrees, the nature of that relationship is 0.5. Let's look at the nature of the relationship of the cosine of 30 degrees. So I've got my adjacent AH, adjacent over hypotenuse. Okay. The nature of that relationship, regardless of the length of the sides, will always be cosine. And as you can see, the bracket comes up again, 30, close the brackets, enter. Oh, cool. I will round this to 6. I was looking at 6. I'll round this to 3 decimal places. If you remember, when we start rounding, that little sign there, when we turn our equivalent sign into a slightly wobbly version, means is approximate to, is pretty close to 0.866. And finally, so regardless of the length of my adjacent and hypotenuse, the nature of the relationship where I get a 30 degree angle is going to be 0.866. Hopefully you can see already how reorganizing formulas can help us find those lengths and find angles. but we'll learn about that in the next two videos. Finally, let's have a look at the tangent. So, S-O-H, car, C-A-H, toa, T-O-A. Opposite over adjacent. So let's have a look at what the nature of the relationship between the opposite and the adjacent. Tan, again, the bracket comes up for you. Type in 30 degrees and hit enter. 0.7735. I'll round this to 4 decimal places. Actually, let's round it to 3 decimal places because that's what I did over here. So it is a very close approximate, but approximate to 0.577. Again, the 7 stays the same because the 4th decimal place is below 5. I hope that's helpful. And as I said, in the next two videos, which are integrally linked to this one, we'll learn how to use these relationships to find unknown lengths and unknown angles.